Good morning. In this video lesson, we're going to keep working today, the rest of this week, on solving equations. Today, our specific focus is going to be to start working with the distributive property, something you learned last year with Mr. Neville, and that can help us start solving more difficult equations that we're going to see today. In short, the distributive property, it's a fancy word for taking expressions that are in factored form, where we see parentheses and some number that's been factored out of both terms, and multiplying that factor back into both terms to put it into expanded form. So we see two examples here today. Take a look. You could even pause the video to read through the objectives, the key terms. You do want to know what a like term is. I think you already know that. But I would pause this video right now and make sense of what factored form is, and remember how we went from factored form to expanded form, and even sometimes when we have fractions or negative numbers that are factored outside. That's going to be our key skill today, because what we're going to see for equations that we're asked to solve today, like the green one and the challenge problem in pink or fuchsia pink down here, we have factored form equations. The 4 has been factored out from both 2a and -5 in this case. Down here, the -2 has been factored out of a +2 and out of a -3b term. So I'm going to ask you to pause this video right now and try to work through parts 1 and then part 2. Part 1 says, what is a good first step to try to solve this equation? And then part 2 asks you to actually try to find that solution. I'm going to switch over to my whiteboard while you're doing that, and you've paused the video. And now that you're coming back from working on this on your own, we're going to take a look first at part 1. It says the green equation above is written in factored form. That means this 4 has been factored out of the 2a and the -5 term. That's why we see parentheses. The 4 was factored out of both of these terms inside the parentheses. They ask us, when trying to find solutions to an equation like this, what is a good first step to take in solving them? The first step that I would take each time if I'm trying to solve these is I would distribute. I would apply the distributive property. I would take whatever is outside the parentheses, whatever's been factored out, and we're going to go ahead and full screen now, but your answer here should have been apply the distributive property. And because we're going to see that helps us get rid of the parentheses, it helps us free up this 2a, the variable that we're trying to get all by itself or to isolate. So the big key, whenever I'm solving equations that are in factored form, an awesome method, not the only one, but a great method to solve, is to just apply the distributive property and go into expanded form. That means 4 times 2a, 4 times 2a is going to give us 8a. 4 times 2 is 8. All we have is 8 times a now. 4 times -5, I know a positive times a negative is going to be a negative, and 4 times 5 gives me 20. So 4 times -5 should give us -20. 8a and -20 are not like terms. They don't have the same last name, so I can't combine 2a and -5. I also can't combine 8a and -20. But once I've distributed, you should see this equation looks a lot like the two-step equations that you solved with Mr. Neville last year. We have one variable term that's here in 8a. We have two constant terms in -12 and -20 and +12. Because 8a, the variable term, has already been gathered on the left side of the equation, I want all the constants on the right. I'm going to add 20. The inverse operation of subtracting 20 is to add 20, with the goal of getting rid of the constant term on the left expression, and now it shows up on the right so I can combine it with the like term, the other constant. 32 is now equal to 8a. The inverse operation of multiplying by 8, you might solve this by inspection. Probably a great one to solve by inspection. What number times 8 makes 32? Most of you should know that's 4. But if we're not sure, the opposite of multiplying by 8 is to divide by 8. That would cancel out. Both sides get divided by 8. 32 divided by 8 is another way to realize a is equal to 4. Part 3, and this is important. Part 3 asks us to confirm whether your solution to the equation is correct. Your job is going to be to take this 4, plug it back into the equation. It's going to become 2 times 4. And so if I do 2 times 4, that becomes 8, and 8 minus 5 just becomes 3. So I've taken this answer. I'm trying to check again for part 3. We'll full screen the whiteboard. I plugged in the 4. 2 times 4 is 8. Now I've got 8 minus 5 in the parentheses, which is 3, and I know 4 times 3 is 12. So we've kind of confirmed the solution pretty quickly there, just to save some time. That's going to be your main job today. You're going to be getting equations that look like this. You're going to have to distribute to solve more difficult equations now. I'm going to run through an optional challenge problem with you. This is to help you on some of the later problems today. You don't have to work through this right now. If you want to get going on the practice problems, please go ahead to jump right down to the practice problems. That's problem number 1. We see this red equation here. But if you want to learn how to do the more challenging ones, take a look here. I'm going to replace my whiteboard. You should have paused the video trying to apply your skill now and solve that fuchsia pink equation. A little more complicated. Now that you've paused the video and you've worked on this on your own, first step you should have seen again is going to be to distribute. I'm going to distribute the -2 to that variable term, the -3b, and I'm also going to distribute it to the constant, a +2. -2 times +2 leaves us with a -4. And a negative number times another negative, -2 times -3b gives us a +6b. 2 times 3 is 6, negative times a negative is positive, and we have b. -2b equals -16. Now we have 1, 2, 3, 4 terms. 2 of those, circled in red, are constants. 2 of those, boxed in blue, are variable terms. The river here helps me recognize my 2 variable terms have already been gathered, already on the same side of the equation. 6b minus 2b should be simplified or combined to make a +4b. Still have the -4, still have the -16, but now at the end of the day, I've at least got my variable terms gathered and combined on the left expression. If that's the case, I want the constants on the right. -4 gets moved with a +4. Because +4 is the inverse of -4, that sends it over here. -16 plus 4 is -12. A lot of methods to get there to -12. We don't have the time to go through them. Talk to me if you need help there. 4b is left over. 4b equals -12. What number times 4 is 12? That's 3. And I need a negative times a positive to get to a -12. So b is going to be equal to -3. I don't have the time right now, but you should be taking that -3, plugging it back into this equation, seeing if it works, because I'm not even sure if this is the correct answer yet. Good luck on the rest of the problems. Let me know. Let Miss Stewart know if you've got any questions, need any help. Thanks for watching to the end of the video.